Hello everyone. Today I would like to talk about permutation in string. Permutation simply means reordering. So this question gives you two strings S1 and S2. Asks you to return true if S2 contains a permutation of S1 or false otherwise. The solution is the same as the other question, find all anagrams in a string. Please feel free to look it up in my videos if you're interested. So let's look at the example. S1 equal to AB, S2 equal to EID, BA, OOO. So this BA is a permutation of AB, so the answer is true. Let's look at the constraints. So S1 and S2 has a length between 1 and 10 to the power 4, and they consist of lowercase English letters. So we don't need to do any case conversion. And how about the length of S1 and S2? Does it say anything about which one is larger than the other one? It doesn't. But obvious that if the length of S1 is greater than the length of S2, there's no answer. Okay, and it also consists of only English letters, so we might be able to use a character counter that's order independent, like a hash map. With some basic brainstorming done, let's start to implement the coding. So we know that if the length of S1 is greater than length of S2, there will be no answer. And now let's convert it to the character counter. So counter S1 will be like this. Counter S2 will be like this. And so first of all, we would like to fill in the same number of characters in both counters. So range length S1. So we want to use the length of S1 to fill in both. So counter S1 I. So that will be S1 I, which is a character, and the ordinal of this character, and the minus 8 and plus equal 1. So that's the counter, and counter S2 the same. So now S1 and S2 counter has this same length. Now we're going to process the remaining. So for I equal in range length S2 S1 S2, so we're going to process the remaining. But so if they are already the same, we can return true. Otherwise, we'll continue to process here. So if in this range, we want to add one character into the counter of S2. So S2 I, we want to add, and then we also want to subtract the previous one. So for example, let's say this is 2 and 7 in the length, and so to begin with, both of them are 2, okay, and then it's okay to subtract 2 here, so this becomes 0, and this is minus equal 1. And if counter S1 equal counter S2, then return true here. Finally, if after all this, nothing happened, we return false. Okay, and that's the code, and I think it will work. So let's test this. We submit, and that's it. It works. So here, for the time complexity, we do this part. So this part has the O length of S1, and then we do the remaining part. So the remaining part has length of S2 minus length of S1, and in each remaining part we compare to the counter will be 26. So this is the time complexity. And the space complexity will be O 1, since we use a fixed size counter throughout. So that's the answer. So this is example that we can also walk through a case like AB S1 S2 is like EL BAC. So in this counter S1 will initially be 1 1 and followed by a lot 0. Counter S2 will be 0 0 0 0 1, because this is the E, and another one for the L. Okay, so there's an EL, and then counter S2 will update like it add a B minus E, add A minus L until they are the same. Okay, so once it add A minus L, they'll be the same. So which means this sliding window has matching order independent with S1. Okay, so the technique here is sliding window and order independent counter. Okay, I hope this video is useful. Please feel free to subscribe for more videos if you like. I hope to see you next time soon. Goodbye.